Vandenberg Space Force Base sits on a stretch of California coastline about 160 miles north of Los Angeles, and on a clear night, a launch from there lights up windows from Santa Barbara to San Diego. Tonight, a rocket goes up a little after 9. The first stage drops away, flies itself back down, and lands on a barge in the Pacific. That is the part that makes the news. The part that matters here happens quietly. About an hour later, 200 miles up, the nose cone came off minutes into the flight. Long gone. Splashed down offshore. The second stage has coasted into position. Now, a dispenser rack releases its grip, and satellites start coming off, one at a time. Tensioned rods pushing each one clear before the next lets go. 1, then 8, then another rack, then another. By the time the sequence ends, that single rocket has scattered 28 separate machines across the sky, each with its own solar panels, its own radio, its own entry in a catalogue. So was that one launch, or 28 spacecraft? Sit with that, because it breaks something. Ask how many spacecraft humanity has sent into space, and you get 4 answers. All official, none of them the same. About 27,490 satellites placed into orbit since 1957. About 18,840 still up there. About 16,100 still working. And barely 300 machines that have ever left Earth orbit at all. 4 numbers. All correct. And the gap between the biggest and the smallest is a factor of 90. Somewhere inside that gap is the real answer. And getting to it means doing something nobody warns you about first. Before we can count the spacecraft, we have to decide what a spacecraft is. Start with 2 rooms about 3,000 miles apart. The first is at Vandenberg, in a building most people on the base will never badge into. This is where the United States tracks objects in orbit. Radar stations in Alaska, in Greenland, on an atoll in the Marshall Islands, and a dozen other places feed observations in around the clock, and anything big enough to follow gets a catalogue number. The numbers run in sequence, and they started at the beginning. Sputnik 1's spent rocket body took number 1. Sputnik 1 itself took number 2. That catalogue has been running ever since, and recently passed 60,000 entries. The second room is an office in Cambridge, Massachusetts, where an astronomer named Jonathan McDowell keeps a list. McDowell studies black holes and X-ray sources for a living. The list started as a side project decades ago and turned into something else. It is a record of every launch, every payload, every object our species has put into space, cross-referenced, corrected, and updated continuously, maintained by one guy. When the official catalogues contradict each other, which happens more than you would think, people inside the industry check his version. Agencies cite it. Reporters cite it. It is a spreadsheet, on a personal computer, in an office, and it is one of the most trusted counting records humanity owns. The fact that it has to exist tells you the question is in trouble, because here is what happens when you go to the official sources and ask how many spacecraft we have sent. The United Nations keeps a register in Vienna. Every country that signed the treaty is supposed to report what it launches. That gives you one number. The Space Force keeps the tracking catalogue at Vandenberg. Different number. The European Space Agency runs a database in Germany that models the whole orbital environment, down to fragments too small for any radar to see individually. Different number again, and McDowell's list, often the most careful of the 4, matches none of them exactly. These organisations are not sloppy. They employ some of the sharpest orbital analysts alive. They disagree because they are counting different things. And nobody ever made them agree on definitions. Because for most of history, nobody needed to. Take the biggest number first, since it is the one that shows up in headlines. The surveillance networks currently track about 46,110 objects in orbit. That figure is real. It is also close to useless for our purposes. because most of those objects are not spacecraft by any standard you would accept. Spent rocket stages, clamp bands and lens caps, fragments from things that broke, and a few hundred entries labelled unknown, which means a radar is tracking a thing. The thing has a number, and nobody can say what it is or where it came from. So 46,000 tracked objects does not mean 46,000 satellites. Pull out the stages, the hardware, the shrapnel, and the mysteries, and the number drops by more than a third before we have argued about a single definition. Now the other end, NASA puts the number of robotic spacecraft that have ever left Earth orbit, the ones that actually went somewhere, at a little over 300. 300 against tens of thousands. Sit with that ratio, because it is the shape of this whole story. Almost everything we ever launched stayed home. The famous machines, the ones with documentaries and postage stamps, are a rounding error on the real total, and the real total depends entirely on where you draw lines. Does a satellite that reached orbit dead on arrival count? Are the Apollo Command Module and Lunar Module 1 spacecraft or 2? Is a station assembled from 16 separately launched pieces one thing or 16? Does a probe we deliberately crashed into a comet still count after impact? Every one of those questions splits the books a different way, and every organisation keeping books has answered them differently. So we are going to do this properly, from the beginning, and be honest about the rules as we write them. 2 counters run through everything that follows. The first is the broad count. Every purpose-built machine humanity successfully placed into orbit or beyond, whether or not it ever worked as intended. The second is the far count. Only the machines that left Earth orbit and went somewhere else. Right now, both counters read the same thing, which is nothing, because we have not agreed on the rules yet. One thing before we start writing them, in case any of this feels distant, wherever you are watching this, there is a phone within reach of you, and if you open the map on it, that little blue dot showing where you are is being computed right now from signals sent by 4 separate entries in this ledger, hanging 12,000 miles over your head. This count is not a trivia exercise about faraway machines. Most of it is infrastructure, and you have been using it all day. We will get to what all 27,000 of them are doing up there. First, we have to go back to the night the number was 0. And then, for the first time in the history of our species, it was not. On the evening of October 4th, 1957, a ham radio operator in the Midwest tuned down to a frequency just above 20 megahertz and heard something that had never been on the air before. A tone, steady and artificial, pulsing about 3 times a second. It faded in as the source came over one horizon and faded out as it went down over the other. And about 96 minutes later it came back. That sound was coming from a polished aluminum sphere 22 inches across, weighing 184 pounds, moving at 18,000 miles an hour, 500 some miles up. Radio Moscow announced it that night. American stations had it within hours. RCA engineers recorded the signal at a listening post on Long Island, and by the next morning the recording was playing on NBC while the country ate breakfast. Newspapers printed the past times the way they printed train schedules, so people would know when to go out and look, and people went out. In backyards from Maine to California that week, before dawn and after supper, families stood in the dark looking for a moving point of light. Millions of them found one. Hardly any of them were looking at Sputnik. The satellite was a 22-inch ball. At that altitude it was far too small and too dim to see with the naked eye. What crossed the sky over America that week was the rocket body, the spent upper stage that had carried Sputnik up and then followed it around the Earth. Nearly 100 feet of metal, tumbling, flashing sunlight with every rotation. The most watched object of 1957 was not the spacecraft. It was the container the spacecraft came in. On the first night of the space age, the count was already confused. 2 objects were up there, and the whole world was pointing at the wrong one. Hold that, and let the count begin anyway. One machine, built by people, circling the Earth, doing a job. The job was modest. Sputnik carried a radio transmitter, silver zinc batteries, a fan, and a temperature switch that changed the pulse timing as the interior warmed and cooled. Its whole purpose was to be heard. It transmitted for 22 days until the batteries went flat, and it burned up on re-entry 3 months later. But for those 22 days, the broad count read 1, and any farmer in Kansas with a shortwave set could confirm it personally. It read 2 on November 3rd, and the second entry gets complicated fast, because Sputnik 2 carried a passenger, a dog named Laika, pulled off the streets of Moscow, sealed into a pressurized cabin with food and a waste system, and no plan for coming home. The cabin's cooling system failed. She died within hours of reaching orbit, and the Soviet government did not admit that for 45 years. The ledger does not have a column for it. It records a functioning spacecraft, and it says nothing about what the spacecraft carried, which is the first sign that a ledger and a story are two different documents. The American answer was supposed to come in December. The Navy's Vanguard rocket stood on its pad at Cape Canaveral on December 6th, with a grapefruit-sized satellite on top and the national press watching. Because unlike the Soviet launches, this one was public. It rose about 4 feet. Then it settled back down and blew up. Keep an eye on that grapefruit. We will come back for it near the end. And what happened to it is one of the strangest counting problems in the whole ledger. The real American answer went up on the last night of January, 1958, on an Army rocket built by the team at Redstone Arsenal in Huntsville, Alabama. Explorer 1 was a slim cylinder, 6 inches across, about 30 pounds. It carried a cosmic ray detector built by James Van Allen's group at the University of Iowa, and within months that instrument had found the belts of trapped radiation wrapped around the Earth that now carry Van Allen's name. The Soviets orbited first. The third satellite in history made the first major discovery of the space age. Broad count 3. Then, in March of 1958, came the entry that matters most for us, and almost nobody remembers it. Vanguard 1 flew on the program's next satellite attempt and reached a high, stable orbit, 3 pounds, 6.5 inches across, and it was the first satellite to run on solar cells rather than batteries alone. The battery-powered transmitter quit in weeks. The solar-powered one kept talking until 1964. Then Vanguard 1 went silent. It did not come down. It is still up there tonight. 68 years of circling. Dead. Intact. The oldest human-made object in space. In an orbit stable enough that it should stay put for roughly another 2 centuries. Sputnik burned up in 3 months. The famous one is long gone. The little American sphere nobody talks about is the senior member of everything now in orbit. And it will still be there when everyone watching this is not, which forces the first real rule of the count. Vanguard 1 does no work. It answers no one. By any functional test it stopped being a going concern while Lyndon Johnson was in the White House. But it is a spacecraft. Whole and recognizable. In orbit. And no honest ledger can pretend otherwise. So the rule is this. We count machines that were placed in space with a job of their own. Going quiet does not remove an entry. The count is a record of what we sent. And what we sent does not unhappen when a battery runs down. That sounds clean. It will not survive the 1960s. By the end of 1958, the broad count stood at 7 or 8, depending on a definitional argument we will get to shortly. Every one of those entries was its own launch. One rocket carrying one machine. And everybody assumed that was simply how it worked. The far count still read 0. Nothing built by human hands had left the neighbourhood. And the boundary of that neighbourhood, the line between the sky and space, turned out to be an argument all by itself. It cost a group of American test pilots their astronaut wings. The first machine ever to reach space was not chasing science, and it did not go up in 1957, on June 20th, 1944, at a test range at Peenemünde on the Baltic coast. German engineers stood a V-2 rocket on its pad and aimed it straight up, not downrange at a target, vertical, as a performance test. It climbed for about 5 minutes and topped out around 176 kilometers, roughly 109 miles above the Earth. That is space by every definition anyone uses today. A machine built by human hands crossed the boundary 13 years before Sputnik, and the machine was a weapon, assembled by slave labour from concentration camps, designed to fall on London. The space age has a birthday everyone celebrates, and an older one nobody does. So does the V2 count. It reached space, and it did not stay. It coasted up, arsed over, and fell back into the Baltic the way a thrown baseball comes down. Total time above the line. A couple of minutes. That distinction between touching space and staying in space is one the count cannot live without. To hold it, we have to answer a question that sounds trivial and is not. Where does space actually start? Nothing up there is marked. The atmosphere thins gradually, from sea level pressure to near vacuum, and any line drawn through that fade is a choice rather than a discovery. The most famous choice is the Kármán line, set at around 100 kilometers, about 62 miles, named for Theodor von Kármán, a Hungarian-born aerodynamicist who spent most of his career at Caltech. His reasoning was elegant. Below that region, an aircraft can hold itself up with wings. Above it, the air is so thin that generating lift would require flying at orbital speed anyway. At which point you have stopped being an airplane, where wings quit working. Space begins. The international body that certifies flight records adopted 100 kilometers. The American military and NASA never did. Their working boundary sits at 50 miles, about 80 kilometers. And for a stretch of the 1960s, that 12-mile disagreement decided who got to call himself an astronaut. Out at Edwards Air Force Base in the high desert of California, test pilots were flying the X-15. A black rocket plane dropped from under the wing of a B-52 bomber. It flew to the edge of everything. 13 X-15 flights crossed the 50-mile line, and the Air Force pilots who flew them got astronaut wings, pinned on at ceremonies, written up in the papers. The NASA civilian pilots who flew the same profiles in the same airplane got nothing, because their agency had no such tradition at the time. Some waited more than 30 years for it. Bill Dana, who flew 2 of those missions, finally received his astronaut recognition in 2005, 4 decades after the flights that earned it. Only 2 X-15 flights, both by Joe Walker in 1963, went above 100 kilometers and satisfied the international line as well. So there were men in the 1960s who were astronauts in their own country and not astronauts 100 miles offshore. Depending on which rulebook you opened, the argument never fully died. In 2018, Jonathan McDowell, the same astronomer with the spreadsheet, published a detailed paper arguing the boundary belongs closer to 80 kilometers, near the American line, because that is roughly where a satellite can no longer complete another orbit without burning up. The physics is on his side. The line has not moved, and in the last few years the question went commercial. Suborbital tourist vehicles now fly paying customers on arcs above the boundary. A few minutes of weightlessness, the curve of the Earth through a window, then a parachute or a runway. Those vehicles reach space. So did the V2 in 1944. Neither one stays. Staying is the whole game, and it comes down to speed rather than height. Height is the cheap part. Straight up to space takes a serious rocket, not an extraordinary one. Staying up is a different problem. To keep from falling back, a vehicle has to move sideways fast enough that the surface of the planet curves away beneath it as quickly as gravity pulls it down. Down low, that speed is about 17,500 miles an hour, roughly 25 times the speed of sound. Reaching space is a sprint straight up. Orbit is a permanent screaming fall that never finds the ground. And the energy gap between those two things is enormous. That is the real boundary. And it is drawn in velocity. So the count takes its second rule. And it is strict. Touching space is not enough. An entry has to reach orbit or leave Earth entirely. The V2 stays out. The X-15 stays out. Wings and all. The tourist capsules stay out. Every suborbital flight in history. Hundreds of them carrying instruments and animals, and eventually ticket holders, sits outside the count. Not because those flights did not matter, but because the ledger needs a line that will not move. And orbit is the only line physics will defend for us. The counters hold where they were. Broad count. 7 or 8 at the end of 1958. Far count. 0. Notice what just happened. Though, we wrote a rule, and the rule was a choice. A different, equally defensible choice would produce a different total. Keep that feeling nearby, because the next decade attacks the count from the opposite direction. The problem stops being machines that failed to reach orbit. The problem becomes machines that reached orbit and then refused to stay one machine. July 20th, 1969. About 69 miles above the moon, two vehicles are flying in formation, docked nose to nose, with 3 men inside. Then a set of latches lets go and the vehicles come apart. One of them, a cone and cylinder called Columbia, stays in lunar orbit with Michael Collins alone inside. The other, a 4-legged, gold-wrapped, deliberately ugly machine called Eagle, drops away with Armstrong and Aldrin and starts down. For the next day and a half, the United States has 2 crewed spacecraft at the moon, flying separately, doing different jobs, each with its own engines, computer, life support, and radio link to Houston. One of them lands on another world, the other circles alone, and on every pass behind the moon, Collins loses contact with everything, cut off from the Earth and from the only 2 other human beings within 250,000 miles, for 48 minutes at a stretch. Now the bookkeeping question, and it is not small. How many spacecraft is Apollo 11? The public answer has always been 1. 1 mission, 1 name, 1 line in the history books. But the thing that left Earth was never one thing. It was a stack. At the top, the command module, the cone the crew rode in, the only piece that came home. Behind it, the service module, carrying the main engine, the fuel, the power, and the oxygen, a vehicle in its own right that got cut loose and burned up at the end, and folded into a garage below them both. The lunar module, a complete 2-stage spacecraft that flew on its own, landed on its own, and then split into 2 pieces itself, leaving its descent stage standing on the moon and flying its ascent stage back up. Count the stack as 1, and you are counting a mission. Count the pieces that flew independently, and Apollo 11 is at least 3 spacecraft, one of which was 2. NASA's own engineering documents treat the command and service modules and the lunar module as separate spacecraft. The history books treat the whole thing as 1. Both are defensible, and that is the problem. If Apollo were a one-off, the ledger could carry a footnote and move on. Splitting apart turns out to be one of the most common things spacecraft do, and every era has produced a harder version of the question. In October of 1997, a Titan IV left Cape Canaveral carrying what most newspapers called the Cassini probe, headed for Saturn. That description quietly erased a passenger. Bolted to Cassini's flank was Huygens, a European-built machine shaped like a wok, with its own heat shield, parachute, batteries, and instruments. The 2 flew attached for nearly 7 years, one feeding the other power, and by any casual look they were 1 spacecraft. Then, on Christmas Day of 2004, Springs pushed Huygens away, and it flew alone for 3 weeks before falling through the orange haze of Titan and landing on a frozen plain. 1 launch, 1 trajectory, 2 spacecraft, built on 2 continents, run by 2 control rooms in 2 hemispheres. Galileo did the same thing at Jupiter. The orbiter carried a separate atmospheric probe, released it 5 months before arrival, and the probe hit the cloud tops at over 100,000 miles an hour, survived the fireball, and transmitted from inside the atmosphere of the largest planet in the solar system for 58 minutes before the pressure and heat finished it. 58 minutes of operation after 6 years of riding along. And nobody serious would say it does not count. It went where nothing had ever been and did its job when it got there. The modern era produced the cleanest example of all. In 2018, an Ariane 5 lifted off from French Guiana, carrying Bepi Colombo, bound for Mercury. What sat on top of that rocket was 1 physical stack and 4 distinct machines. A European transfer module doing the flying, pushing everything along with ion engines through a 7-year sequence of planetary flybys. A European orbiter built to map Mercury, a Japanese orbiter built to study its magnetic field, and a sunshade protecting the Japanese craft until arrival. 2 space agencies on opposite sides of the planet each registered their own spacecraft, riding the same rocket, wired into the same stack. The United Nations register lists them separately. 1 launch. The count went up by more than 1, so the vocabulary has to get precise, because the everyday words are doing damage. A launch is an event. A rocket leaves the ground. It can carry 1 machine or 100, and counting launches tells you about rockets. A mission is a project. Apollo 11, Cassini-Huygens, Bepi Colombo. It is a name on a patch and a line in a budget, and it can contain any number of machines. A launch vehicle is the rocket, and it is not a spacecraft. It is the delivery truck. Its stages reach orbit sometimes and get tracked and catalogued. And hold that thought, because rocket bodies come back to haunt this ledger at the very end. And a spacecraft, for our purposes, is a machine placed in space that is built to do its own job once it gets there. The European Space Agency's database draws the line in almost exactly that place. A payload is an object designed to perform a specific function in space, and the function of launching does not count. Columbia qualifies. Eagle qualifies. Huygens qualifies. The Galileo probe, 58 minutes and all, qualifies. The empty stage tumbling behind Sputnik does not. And that is not because its work was brief. It is because its work was getting there. That is Rule 3. And the whole count stands on it. We record machines with their own job, no matter how they got up, no matter how many shared the ride, no matter how briefly the job lasted. Apply it backward and the early ledger quietly grows. Missions history filed under 1 name dissolve into pairs and trios. Apply it forward and the growth stops being quiet. By the end of the 1960s, the broad count is in the hundreds. Weather satellites, spy satellites, communications relays, navigation experiments, moon probes, capsules carrying men and dogs and chimpanzees. The far count has finally opened too. Machines have flown past the moon, crashed into it, orbited it, landed on it, and looped out around the sun. Hundreds of entries, and one assumption still standing underneath all of it. Through the whole first decade, 1 rocket generally meant 1 payload, maybe 2 or 3, and every payload was something a country wanted to announce. Both halves of that assumption were about to die, and the machine that killed the first half released more objects on a single flight than every other launch in history put together. About 10 miles north of Fairbanks, Alaska, on a ridge above the Chena River Valley, there is a field of white domes and dish antennas that most Americans have never heard of. It is a satellite ground station, one of the busiest on the planet. And it sits where it sits because of a quirk of geometry. Satellites that circle the Earth pole to pole pass within view of the far north on nearly every lap. Put your antennas near the top of the world and the sky comes to you. So the dishes at Fairbanks spend all day and all night swinging, locking on, pulling down data, letting go, and swinging again. A satellite comes over one horizon, stays in view, maybe 10 or 12 minutes, dumps everything it recorded since its last pass, and drops below the other horizon. Then the next one rises. On a busy day, one antenna might work dozens of passes back to back. Nearly every machine those dishes talk to lives its entire life within a few hundred miles of the ground. That sentence collides with what most people picture when they hear the word spacecraft. The picture is Voyager in the dark, or a rover cutting tracks in red sand, or a lunar module on its legs. Machines that went somewhere. Pull up the actual ledger, though, all those tens of thousands of entries, and the overwhelming majority never left the immediate neighbourhood. They went up a couple hundred miles, started circling, and circled until they died. Some of the dead ones are circling right now. Roughly 98% of everything humanity has ever launched has stayed in orbit around our own planet. Space, for almost every machine we have ever built, is not a destination. It is an altitude. The neighbourhood comes in layers, and you can hold the whole arrangement in your head with 3 images. The first layer starts just above the atmosphere and runs out to about 1,200 miles. Low Earth orbit, and the image is a freeway with no exits, running at 17,000 miles an hour. Everything here moves at that speed because physics permits nothing else. And everything here laps the planet in roughly 90 minutes to 2 hours. The space station is here. Most Earth observation satellites are here. The big new internet constellations are here. This is where the crowd is. When you hear that space is getting congested, this layer is the congestion. The second layer sits far higher, around 12,000 miles up, and by comparison, it is nearly empty. The image is a thin ring of lighthouses. This is where the navigation fleets fly. The American GPS satellites and their European, Russian, and Chinese counterparts. A few dozen machines broadcasting time signals of almost absurd precision to anyone below who cares to listen. They do not need to be many. They need to be exact. The third layer is a single circle, and it is one of the strangest places human engineering ever colonized. At exactly 22,236 miles above the equator, one lap takes precisely 24 hours, which is how long the Earth takes to turn once underneath. A satellite placed on that circle, moving the same direction as the spin, stops moving across the sky at all. From the ground, it simply hangs there. The image is a shelf. Television broadcasters park on it. Weather satellites park on it, staring at the same hemisphere around the clock. The dish bolted to a house in Ohio never has to move, because the machine it points at never appears to. There is a small population of specialists elsewhere. Satellites on long stretched loops that dive close and swing far out again. Orbits tilted and tuned for particular jobs over particular latitudes. But those 3 layers hold almost everyone. A crowded freeway near the ground. A sparse ring of lighthouses in the middle distance. A fixed shelf over the equator. Here is what reframes the entire count. The distance out to that farthest shelf is about 22,000 miles. The moon is roughly 10 times farther. Mars, at its closest, is more than 1,500 times farther. On a scale model where the Earth is a basketball, the entire zone, holding 98% of every spacecraft ever launched, fits within about 6 feet of the ball. The moon is 60 feet away. Everything else is in another county. We did not spread into space. We built a shell around our own planet, a working layer of machinery wrapped tight against the atmosphere, and we have been thickening it for almost 70 years. The counters feel that immediately. The broad count runs into the tens of thousands. The far count, the machines that ever broke out of the shell, is stuck in the low hundreds. For every machine that left, about 90 stayed home. Everything in this chapter still assumes satellites arrived the way they did in 1958. One rocket goes up. One machine comes off the top. The ledger ticks forward by one. In May of 1963, the United States launched a single payload that put 480 million objects into orbit at once. The problem, in 1961, was the ocean floor. Almost all of America's long-distance communication with the rest of the world ran through undersea cables. And Cold War planners had absorbed an uncomfortable fact about cables. They can be found, and they can be cut. A Soviet trawler dragging the right stretch of the Atlantic could sever the link between Washington and its forces in Europe in an afternoon. The backup was bouncing radio off the ionosphere, which goes haywire during solar storms and, more to the point, during high-altitude nuclear detonations. The Pentagon wanted a way to talk across oceans that nobody could cut and no bomb could scramble. Engineers at MIT's Lincoln Laboratory proposed one, and it is still one of the most audacious pieces of infrastructure thinking of the century. If nature's reflective layer was unreliable, they would install their own. The plan was called Project Westford. A spacecraft would carry a payload of copper needles, each about 7/10 of an inch long and thinner than a human hair, each cut to exactly half the wavelength of the frequency the military intended to use, which turned every individual needle into a tiny, tuned antenna. Released in orbit and allowed to spread, they would form a belt around the entire planet, a diffuse metallic haze that microwave signals could bounce off, an artificial ionosphere, built in Massachusetts. The number of needles in the dispenser was 480 million. The first attempt in 1961 failed when the needles came out in clumps instead of spreading. The second flew on May 9th, 1963, and this time it worked. Over the following weeks, the needles dispersed along their orbit into a belt thousands of miles long, and voice transmissions successfully bounced between an antenna in California and an antenna in Massachusetts, off a cloud of copper hair suspended 2,000 miles up. Then communication satellites got good in a hurry. The belt was obsolete within a couple of years, and it was never used operationally again. Now, the accounting question, and there is nothing else like it in the ledger. What did that launch actually place in orbit? One payload. By the count of dispensers, 480 million objects. By the count of things, each needle was a working piece of the system, and the system worked. If we count machines that perform a job in space, does a belt of 500 million antennas count as one entry, or as a number that would swamp everything else our species has ever done by a factor of thousands? Every catalogue on Earth answered the same way, and it is the only answer that keeps the books sane. The needles were counted as a payload, singular, plus the handful of clumps that failed to disperse, which got tracked as distinct objects. The individual needles were never catalogued and never will be. Most were pushed back into the atmosphere by sunlight pressure within a few years, as designed. The clumps from both launches are still up there, more than 60 years later. Dozens of tracked clusters of Kennedy-era copper, with estimates of thousands more too small to follow. Astronomers, whose radio telescopes the belt threatened to pollute, protested loudly enough that the episode helped push the world toward the first real rules about what you may leave in orbit. Hold on to what Westford proves. The count is a set of decisions. Nature does not tell you what one spacecraft is. A committee does. That lesson sat quietly in the books for 50 years. A Cold War oddity. Until the industry that launched 2 or 3 payloads on a good rocket turned into something else. The change has a rough birth year, around 2015, and 2 causes that fed each other. The first was miniaturization. Electronics that once demanded a satellite the size of a school bus now fit in a box you could carry onto an airplane. A standard emerged. The CubeSat, built from 4-inch cubes. And suddenly, a university lab, a startup, A high school with a good sponsor could build a real working spacecraft for the price of a house. The second was the rideshare. Launch companies started selling rocket capacity the way airlines sell seats. And one booster stopped, meaning one customer. Dispensers were built to hold dozens of small machines like dishes in a rack and spring them loose one after another once the upper stage got where it was going. In January of 2021, one Falcon 9 took off from Cape Canaveral and released 143 separate spacecraft. A record at the time. Communications satellites, radar images, science experiments, technology demonstrators, machines from dozens of companies and countries, all sharing a ride. The 1958 arithmetic was not merely outdated, it was off by 2 orders of magnitude. Riding above all of it is the Constellation era, the big internet fleets. Thousands of nearly identical satellites launched in batches of 20 and 60 at a time, week after week, have done something to the historical totals that is hard to overstate. It took humanity about 60 years to place its first 9,000 or so satellites in orbit. The next 18,000 took roughly a decade. In 2025 alone, by the European Space Agency's ledger, more than 300 launches carried over 4,000 new payloads up. The heaviest year of traffic in history. Plot the broad count against time and the line crawls for 60 years. Turns a corner and goes nearly vertical. And the corner is labelled with this decade, which resurrects the West Ford question in a modern suit. A 6-ton television satellite parked on the geostationary shelf. Built over 5 years. Designed to last 20. A 4-inch cube built by undergraduates. Designed to last 8 months. The ledger counts each of them as exactly one. And there is something absurd in that. And every alternative is worse. Weight the count by mass and one heavy station module outvotes 100 working science machines. Weight it by cost, by lifespan, by usefulness. And the ledger stops being a count and becomes an opinion. So the rule holds, and it is Rule 4. One machine with its own job is one entry. Whether it weighs 6 tons or 6 pounds. Whether it lives 20 years or 20 minutes. Whether it flew alone or came off a rack with 142 roommates. The needles keep their asterisk. The only one of its kind. 500 million working objects recorded forever as one, carried to the present under that rule. The broad count stands at roughly 27,500 machines placed in Earth orbit since Sputnik. Still climbing at the steepest rate in history. The far count barely moved in this chapter. Because dispensers and constellations and rideshares all serve the shell around the Earth. None of them are the road out. 27,000 machines. Which raises the obvious question, what are they all doing up there? The answer is not out in space. The answer is in the cab of a truck rolling west across Nebraska at 4 in the morning. 4 in the morning on Interstate 80, west of Kearney, Nebraska. A long-haul driver is 11 hours into a run from Chicago to Denver, and the road ahead is a straight black line through corn stubble with nothing on it but reflector posts and the occasional deer standing too close to the shoulder. Nothing in that scene looks like spaceflight. Every part of it is running on spacecraft. Start with the screen suction cupped to the windshield. It knows where the truck is to within a few feet. Continuously. At 70 miles an hour. In the dark. In one of the emptiest counties in America. It knows because it is listening to at least 4 satellites at once. Each about 12,500 miles overhead in that middle ring of lighthouses. Each carries atomic clocks accurate to about a billionth of a second a day. And each does nothing all day but broadcast the time and its own position. Over and over. Forever. The receiver hears 4 of those timestamps. Measures how much later each one arrived than it should have. And turns those tiny delays into a spot on the surface of the Earth. That is the whole trick. The most transformative utility of the modern age is a handful of very precise clocks calling down their own name and address from 12,000 miles up. The driver has never thought about any of that. Which is the point. The system was built by the Air Force to guide ships and bombers, open to civilians by degrees, and it has dissolved so completely into American life that it only becomes visible when it hiccups. Nobody looks at the sky and thinks about it. It is just the blue dot, and the blue dot is always right. Now the weather. Somewhere over the Gulf tonight a storm is organising, and the forecast on the truck radio, the one that decides whether tomorrow's run goes south or waits a day, traces back to a satellite parked on the geostationary shelf, staring at the same hemisphere without blinking. The current generation of American weather satellites photographs the full disk of the Earth every 10 minutes and can lock onto a developing storm and image it every 30 seconds. Invisible light and infrared, day and night. It maps lightning strikes from orbit, individually, in real time. Forecasters watching a hurricane no longer check on it hourly the way their predecessors did. They watch it move, frame by frame. Like traffic, the fuel stop outside North Platte. The driver swipes a card and the terminal approves it in about 2 seconds. Buried in that transaction is a timestamp, and the timestamp is not negotiable. Modern banking runs on synchronized clocks, because when millions of transactions cross networks every second, the order in which they happened is the difference between a functioning financial system and chaos. The clocks that keep American commerce agreeing with itself are disciplined by the same satellite signals the windshield unit uses for position. So are the cell towers along the interstate, which need that timing to keep their signals from stepping on each other. So does the power grid, which uses satellite-synchronized sensors spread across the country to catch instabilities before they cascade. Position was the famous product. Time is the one the country actually got addicted to. Past the edge of town, a farmhouse sits a quarter-mile off the road with one light on and a small white dish bolted to the porch roof, tilted at the northern sky. 5 years ago, that house had no internet worth the name, because no company was ever going to run fibre to one family at the end of a gravel road. Tonight, the dish is tracking a procession of satellites sliding across the sky a few hundred miles up, handing its connection from one to the next the way a driver hands off between cell towers, and the household gets city-grade broadband in a place the cable companies wrote off decades ago. There are millions of those dishes now, on farmhouses and fishing boats and cabins and disaster shelters, and the constellation serving them is the largest fleet of spacecraft ever assembled. Thousands of machines, every one of them counted individually in the ledger, and the truck radio itself, playing a rebroadcast ballgame out of Chicago, pulls its feed off the same geostationary shelf that carries the weather picture. Add it up. One driver. One ordinary night. And he has touched the navigation ring. The weather watchers. The timing backbone. The broadband constellations. And the broadcast shelf. All before sunrise. Without once thinking about space. That is what the 27,000 were for. Of the roughly 16,100 spacecraft working right now, by ESA's current ledger, nearly every one is aimed down. They navigate, photograph, relay, timestamp, and measure soil moisture and sea level and wildfire smoke. The fleet is not exploring the universe, it is running the country underneath it, and every other developed country besides, quietly, around the clock. From inside the shell, the machine age above the atmosphere turned out to be a public utility. Nobody threw a parade for it, because it never had a single dramatic moment. Just 7 decades of accumulation. One working machine at a time. 16,100 working machines. Though, is not the whole population up there. The ledger says 27,500 went up, and close to 19,000 are still present. Subtract. And a few thousand machines are still in orbit and no longer answering anybody. The most indestructible spacecraft America ever launched cannot break, because there is nothing on it that works. It is called Lagios. It went up in 1976, and it is a brass and aluminum sphere 2 feet across. weighing about 900 pounds, covered in 426 glass corner reflectors, the same optics that make a highway sign light up in your headlights. No engine, no radio, no battery, no computer, no solar panel, no moving parts. It is a cannonball dimpled with mirrors. Laser stations on the ground fire pulses at it, time the reflection, and measure the distance to within a fraction of an inch. And from those measurements, geophysicists track the drift of continents and the slow breathing of the planet's gravity field. Nothing on Lagios can fail, so Lagios cannot die. Its orbit, about 3,600 miles up, is stable enough that it should stay there for over 8 million years. The designers knew it, and they bolted a small plaque inside, designed by Carl Sagan, showing the arrangement of the continents in the deep past, the present, and the far future, addressed to whoever eventually retrieves it, on the assumption that 8 million years is long enough for the answer to be interesting. Lagios sits at one extreme of this chapter's question, entirely passive, entirely useful, permanently silent because it never had a voice to begin with. Now, the other extreme. A few hundred miles up tonight, there is a communications satellite launched in the 1980s that had a perfectly ordinary career and then, one day in the 1990s, ran low on the fuel it needed to hold its position. Its operators nudged it into a slightly different orbit, shut it down, and walked away. It has been flying ever since. Solar panels degraded, batteries long dead, tumbling slowly, a bus-sized piece of American engineering that no living person has thought about in 30 years. Nothing about its motion distinguishes it from a working satellite. It simply never speaks. The arithmetic from the last chapter gives us the size of that silent population. Roughly 27,500 machines placed in orbit. Roughly 18,840 still up there. Roughly 16,100 still working. So the shell currently holds a few thousand intact, dead spacecraft. And beneath that, history has already retired thousands more, the hard way. Does the dead fleet count? It has to. And the reason is that the alternative wrecks the ledger. A count that drops machines when they quit working is not a record of what humanity sent into space. It is a payroll. Vanguard 1 went silent in 1964 and is the oldest human object in orbit. Lagios never transmitted at all and may outlast the species. We record what we put there. Dying does not unput it. Rule 5, and it is the shortest one. Dead still counts. Never shrapnel. That second half matters, because the public conversation blurs it constantly. The tracking networks follow about 46,110 objects. Working spacecraft make up about 16,000 of them. Dead spacecraft, a few thousand more. The rest is rocket bodies, deployment hardware, and fragments. And the fragments outnumber everything else combined. Only the first two groups are spacecraft. Every headline announcing 46,000 satellites in orbit is counting the shrapnel. 3 dates in the historical record of orbital debris explain most of that shrapnel. January 11th, 2007. China tests an anti-satellite weapon against one of its own dead weather satellites. Fengyun 1C, 540 miles up. The interceptor hits at a closing speed around 18,000 miles an hour, and the satellite becomes more than 3,500 trackable fragments. The largest debris event in history. The altitude was high enough that most of those pieces will stay up for decades or centuries. One test, and the catalogue grew by more than the entire first 15 years of the space age. February 10th, 2009. Over Siberia. An operating American communications satellite. Iridium 33. And a dead Soviet relay satellite. Cosmos 2251. Arrive at the same point in the sky at the same instant, at a combined speed of about 26,000 miles an hour. Nobody fired anything. The dead one could not be steered. The warnings were imprecise. And the working one was not moved. Both machines ceased to exist, and roughly 2,000 more trackable fragments joined the shell. It remains the only major collision between two intact satellites, and the phrase "so far" is doing a lot of work in that sentence. November 15th, 2021. Russia destroys its own dead satellite. Cosmos, 1408. In another weapons test, adding some 1,500 trackable pieces at altitudes that crossed the orbit of the International Space Station. The 7 people aboard, 4 of them Americans, spent that day sheltering in their return capsules with the hatches ready to close, waiting to learn whether their station was about to be hit by the wreckage of a machine launched before most of them were born. 3 events. Around 7,000 catalogued fragments, plus uncountable smaller pieces below tracking size. The dead fleet does not merely sit there. Once in a while it detonates, collides, and multiplies, and every fragment inherits its parent's speed. The dead also come home. The atmosphere has no clean edge, and its thin outer reaches drag on everything in the lower shell. Most dead machines eventually spiral down, and these days, on average, more than 3 tracked objects re-enter every day. Nearly all of it arrives as ash and ocean splash. That steady subtraction is why 18,840 remain out of 27,500 sent. So the shell holds a working fleet, a dead fleet flying in formation with it, and a fog of fragments around them both. 2 of those 3 go in the ledger. Every machine counted so far, working or dead, shares one thing: none of them ever carried a person. The ones that did break the arithmetic in a brand new way, because some of them went to space more than once. There is a photograph taken inside the orbiter processing facility at Kennedy Space Center that shows the Space Shuttle Discovery with most of its skin off. Access panels removed. Engine bay empty. All 3 main engines pulled out. Technicians on scaffolding, reaching into cavities in the airframe. The vehicle looks less like a spacecraft between missions than like a patient on a table. That was routine. After every flight, each orbiter got towed into that building and taken apart. Engines out. Inspected. Often swapped. Thousands of heat shield tiles checked one at a time. By hand. Miles of wiring examined. Landing gear rebuilt. Months of work by thousands of people. Then reassembly. A new external tank. New boosters. A rollout to the pad. And another flight. Then it came home and they did all of it again. Discovery went through that cycle 39 times. 39 trips to space. The record for any vehicle ever built. So what does Discovery count as? 1 spacecraft? Or 39? The program makes the question sharper. NASA built 5 orbiters that flew in space. Columbia, Challenger, Discovery, Atlantis, Endeavour. Between April of 1981 and July of 2011, those 5 airframes flew 135 missions. Count airframes and the shuttle adds 5 entries. Count trips and it adds 135. The 2 answers differ by a factor of 27 and describe the same 30 years of flying. For the first half-century of spaceflight, this problem never came up, because almost nothing came back in flyable condition. Every Mercury flight expended its spacecraft. Every Gemini. Every Apollo. Every Soviet capsule. 1 airframe. 1 flight. Over. The original arithmetic worked because the hardware cooperated. Machines did not repeat. The shuttle broke that, and the current era buried it. SpaceX's Dragon capsules are built to fly, splash down, be refurbished, and fly again. And individual capsules have now made 5 or more trips, some carrying astronauts on one flight and cargo on the next. The company keeps a small fleet of them in rotation the way an airline rotates aircraft. Boosters land and refly. Crewed vehicles refly. So the count needs a ruling. And here it is. Rule 6. We record machines built, never trips taken. Discovery is one spacecraft. A Dragon with 5 missions behind it is one spacecraft. The question we are answering is how many machines humanity has made and sent. And a machine does not become a new machine by going twice, any more than a ship becomes a new ship on its second crossing. That sounds obvious right up until it meets the largest crewed machine ever flown. The International Space Station has been in orbit since November of 1998. And it did not go up. It went up in pieces, on more than 40 separate launches across 2 decades. American shuttles carried segments in their payload bays. Russian rockets lofted whole modules that flew themselves to the rendezvous and docked under their own control. The first piece, a Russian-built module called Zarya, flew alone for weeks. Then a shuttle brought up the American node Unity and bolted the two together in orbit. And construction went on from there, truss by truss, module by module, solar wing by solar wing, until the assembled station weighed close to 1 million pounds and stretched longer than a football field. So what is it? We count machines built, and the station was built. But it was built in the sky, out of parts that were themselves complete spacecraft when they launched. Zarya had its own engines, power, and control system. It qualifies under every rule we have written. So does the Russian service module Zvezda. Many of the American segments, by contrast, were inert structure, unable to do anything until attached, which makes them cargo rather than spacecraft under Rule 3. The correct answer is that the station is one operating spacecraft today, assembled from roughly 16 pressurized modules, some of which launched as independent spacecraft and some as components. And the honest entry is a bracket rather than a number. The United Nations Register handles it by listing pieces under the countries that launched them. So the most expensive object ever constructed appears in the world's official registry as a scatter of entries across 5 space agencies. China ran the same play on a smaller board. Tiangong went up as 3 large modules on 3 launches in 2021 and 2022 and has been permanently crewed since. Fold the crewed total together and one design dominates it in a way most Americans would not guess. Soyuz has been flying since 1967, in continuous evolution. Well over 150 airframes, every one of them expended. Every one a separate entry. That single Russian capsule line outnumbers every American crewed vehicle ever built. Combined, add Vostok, Mercury, Gemini, the Apollo stacks with their multiple machines apiece, Shenzhou, the shuttles, the Dragons, Orion, plus the stations themselves, Skylab and the Salyuts and Mir and the ISS and Tiangong, and the crewed ledger lands somewhere in the low 400s of individual machines. Depending on how you slice the Apollo stacks and the station brackets, every ambiguity in that sentence is a rule we have already written. One last note before the crewed count closes, and it is a strange one. Every machine in this chapter stayed inside the shell. Since Apollo 17 came home in December of 1972, no human being, and no vehicle carrying one, has left Earth orbit. 54 years of continuous human spaceflight, all of it within a few hundred miles of the ground. The machines that did leave went alone, and the first thing waiting out there is a rule-breaking so spectacular it takes a stopwatch to describe. 7 minutes over Mars, in which one spacecraft came apart into 6 separate objects with 6 separate fates. February 18th, 2021. In a control room at the Jet Propulsion Laboratory in Pasadena, masked engineers, it is the middle of the pandemic, are watching telemetry from a spacecraft arriving at Mars, and the room knows something the public broadcast never quite conveys. Everything about to happen has already happened. Mars is 11 light minutes away tonight. Whatever that machine did, it did 11 minutes ago. alone, with no chance of help. Nobody is watching a landing. They are watching a recording of a landing that already ended, and they do not yet know how. What hits the top of the Martian atmosphere at 12,500 miles an hour is called Mars 2020. The public knows it as the rover Perseverance. It is worth looking closer, because in the next 7 minutes, this thing comes apart in a way that makes counting by launches hopeless. 10 minutes before atmospheric entry, the first separation, the cruise stage goes. That is the ring of solar panels and thrusters and radiators that flew the whole stack from Earth for 7 months, doing the navigating, making the course corrections, keeping everything powered and alive. Its job is finished, and it follows its own path into the atmosphere and burns. Pause on it, because it deserves better than it gets. The cruise stage had its own power, its own propulsion, and its own job, performed for 7 months across interplanetary space. Under Rule 3, it is a spacecraft, and no headline ever mentioned it. Next comes the aeroshell, the capsule doing the entering, heat shield below, back shell above, everything precious sealed inside. It takes the fire, around 2300 degrees at the shield face, and it steers, banking through thin air on its own authority, flying itself toward a target zone in a crater that held a lake 4 billion years ago. Then the shell starts shedding, parachute out at supersonic speed, 70-foot canopy, opening shock in the tens of thousands of pounds, heat shield away, falling free to its own impact point. Backshell and parachute released a minute later, drifting down to crash separately, miles from everything else. Those two pieces reach the surface as distinct objects, and the ledger has to make a call on them. So make it now. A heat shield has no propulsion, no navigation, and no job after separation. It is structure. It falls where physics puts it. It stays out of the count for exactly the reason a spent rocket stage stays out. And if the rule bends for a piece of ablative shielding, it will not hold for anything. What the shedding exposes is the strangest flying vehicle America has ever built. The descent stage is a rocket-powered crane, 8 throttleable engines around a frame, with the rover hanging underneath. It flies the last mile by itself, picks its own landing spot with a camera system, comparing the ground below against maps stored in its memory, comes to a hover about 66 feet up, and lowers the rover on 3 nylon cords like cargo out of a helicopter. Wheels touch, the cords are cut, and the descent stage throttles up and flies off at full power, deliberately, to die at a safe distance, which it does, nose down in the dirt about a half-mile away. Then Perseverance rolls its wheels on Mars. 1 ton, nuclear-powered, built to cache rock samples for a future mission to come collect. 7 minutes, 1 name in the newspapers, 6 objects on 6 separate paths, 4 of them now wreckage, photographed later from orbit, scattered across the landscape like the debris field of a very organised crash. And the count is not finished, because bolted under the rover's belly, wrapped in covers, is one more machine. 2 months after landing, Perseverance drives to a flat spot, drops a small package, and backs away. The package unfolds into a 4-pound helicopter named Ingenuity, and on April 19th, 2021, it spins up 2 counter-rotating carbon fibre blades and lifts off, the first powered flight by any machine on another planet. It was a technology demonstration. 5 flights maximum, 30 days. It flew for almost 3 years and made 72 flights before a rotor blade broke on a landing, a machine that rode to Mars as luggage, and finished as one of the most successful aircraft in the history of flight on any world. So, the question this whole act runs on. 1 rocket left Florida in July of 2020. How many spacecraft went to Mars? By mission name. 1. By objects that arrived. 6. By the rules we have written. 4. The cruise stage. which flew the interplanetary leg, the descent stage, which flew itself and landed a rover, Perseverance, and Ingenuity, which is as independent as a spacecraft gets. The heat shield and the back shell were parts of a flight system doing what parts do. 4 entries from one launch. And that is Rule 7. Every component that separates and operates on its own counts on its own, wherever in the trip the separation happens. Structure that merely falls away does not. Once you have that rule, split spacecraft turn up everywhere. Rosetta, the European comet mission, carried a lander called Philae and dropped it onto a comet in 2014, where it bounced twice in the feeble gravity, came to rest on its side under a cliff, worked for 60 hours, and went quiet. 2 spacecraft. The Soviet Vega missions to Halley's Comet in 1986 each dropped a lander and a balloon into the atmosphere of Venus on the way past, and those balloons drifted in the clouds for 2 days apiece. Still the only aircraft ever flown at Venus. 3 machines per launch. Minimum. The reigning champion of the split is a Japanese spacecraft about the size of a refrigerator, and it deserves the fullest accounting we can give. Hayabusa 2 launched in December of 2014 toward an asteroid named Ryugu, a half-mile wide pile of dark rubble. It arrived in 2018 and started releasing things. 2 hopping rovers, 7 pounds each, which moved across the asteroid by flipping themselves in the microgravity, photographing as they tumbled. Then a German-built lander called Mascot, a shoebox of instruments that worked on the surface for 17 hours. Then, in 2019, the mothership fired a copper projectile into the asteroid with a shaped explosive charge, and released a free-flying camera, a separate spacecraft whose entire job was to photograph the explosion while the mothership hid behind the far side. Then Hayabusa 2 came down, collected dust from the crater it had made, and flew home. In December of 2020, over the Australian outback, it released a capsule that streaked in and parachuted to the desert floor carrying about 5 grams of another world. The mothership never stopped. It was redirected onward to a different asteroid it will reach in the 2030s. Count it. Mothership. 2 rovers. 1 lander. 1 deployable camera. 1 return capsule. Plus a guided impactor that counts exactly as much as the one in the next chapter will. 6 or 7 spacecraft. Launched under 1 name on 1 rocket. And 5 grams of asteroid delivered to a sheep station in South Australia. Several of the machines just counted share a property we have skirted around. The impactor, the crashed descent stage, the burned cruise stage. They were built to be destroyed. On the night of July 4th, 2005, most of the country was watching fireworks. At the Jet Propulsion Laboratory, a room full of engineers was watching a countdown to a collision they had spent 6 years arranging. 83 million miles away, a copper-cored machine the size of a washing machine was flying into the path of a comet named Tempel 1, a mountain of ice and rock 4 miles long, closing at 23,000 miles an hour. The machine was the Deep Impact Impactor, and it was not debris, and it was not a warhead. It was a spacecraft in full standing, with thrusters, a camera, and a navigation computer, and it spent the last 2 hours of its existence steering itself, running a targeting program, correcting its aim 3 times, and photographing the wall of ice coming up at it. It sent its final image 3 seconds before the hit. The impact released the energy of nearly 5 tons of TNT, blew a crater in the comet, and threw up a plume of powder that the mothership, watching from 500 miles off, photographed and analysed as it flew past. That plume was the entire point. Comets are leftovers from the construction of the solar system, and the fastest way to find out what is inside one is to hit it hard and read the splash. The 4th of July timing was a coincidence of orbital mechanics, and nobody at JPL pretended to mind, so the ledger has a new species to rule on. The impactor did everything we require. Independent operation. Its own job. Its own systems. It also ceased to exist on schedule. By design. As the successful completion of its mission. It counts. And Rule 3 already covers it. Because nothing in that rule ever said the job had to be survivable. But admitting the deliberately destroyed opens a whole hidden lineage. Because humanity has been aiming spacecraft at things on purpose since almost the beginning. It started at the moon. And it started because stopping was too hard. In 1964 and 65, NASA's Ranger probes flew straight into the lunar surface with cameras running, transmitting continuously until the signal cut to static at the instant of impact. No braking. No orbit. No landing gear. The mission was the crash. Ranger 7 sent back over 4,000 photographs in its final 17 minutes, each one sharper than the last. The first close look at the ground Apollo would have to land on, with the final frame taken about a quarter mile up, a fraction of a second before the machine became a new crater. 3 Rangers worked. The best maps of the moon America owned were the dying transmissions of spacecraft built with no way to survive. Sometimes the projectile was not even the spacecraft. In 2009, a mission called L-Cross took the idea to its logical end. NASA wanted to know whether the permanently dark craters at the lunar South Pole held water ice, and the chosen method was to throw something heavy in and watch. The something heavy was the spent Centaur upper stage of the mission's own rocket, an empty 2-ton fuel tank, which the small L-Cross spacecraft guided to a precise impact in a crater called Cabeus. Then LC-ROS flew through the debris plume itself, sampling and transmitting for 4 minutes before making its own crater a few miles away. The plume held water. Astronauts will someday drink from a discovery made by aiming a fuel tank at the moon. And the ledger notes with a straight face that the tank does not count and the machine that aimed it does. Then there are the endings written for protection. By 2003, the Galileo orbiter was dying at Jupiter, low on fuel, its systems worn down by years of radiation. Left alone, it would eventually drift uncontrolled. And Galileo's own discoveries had made that unacceptable, because it had found strong evidence of a saltwater ocean under the ice of the moon Europa. A derelict could someday hit that moon and seed it with hitchhiking Earth microbes. So in September of 2003, controllers steered Galileo into Jupiter, and the machine that revealed Europa's ocean was vaporized, specifically to guarantee it could never touch the world it made precious. Cassini got the same ending for the same reason. 13 years at Saturn, the discovery of water geysers erupting from the moon Enceladus. Another buried ocean. Another world too important to risk. In September of 2017, out of fuel, Cassini was flown into Saturn's atmosphere, transmitting science until its antenna could no longer hold the lock against the thickening air. The final signal reached Earth early on the morning of September 15th, Pacific time. The room stood and applauded, and some of the people applauding had worked on that machine for 30 years. The modern chapter of this is the strangest, because the target mattered and the spacecraft was the ammunition. In September of 2022, a NASA spacecraft called DART flew into an asteroid named Dimorphos at 14,000 miles an hour, on purpose, with the stated goal of moving it. Dimorphos was no threat to Earth. It was a test range, a small asteroid orbiting a bigger one, chosen because the push would be measurable. The impact shortened its orbit by about 32 minutes, far more than predicted, and proved for the first time that our species can change the path of a body in space. Planetary defense stopped being a movie plot that afternoon, and riding along, released 2 weeks earlier, was a briefcase-sized Italian spacecraft called Lycia Cube, which flew past the site 3 minutes after the hit and photographed the debris spraying off the asteroid. Even at the moment, one machine gets erased. Rule 7 adds another one. The witness. Machines that photographed their own deaths at the moon. A machine that threw a fuel tank. Machines executed at Jupiter and Saturn to protect oceans they discovered. A machine that punched an asteroid onto a new orbit, and the small one that watched. Everyone completed its mission by being destroyed or by destroying. And everyone stays in the books permanently. The United Nations Register has no column for cease to exist. An entry, once made, stands. We record that a machine was sent. What became of it is history's department. That principle has a flip side. If destruction does not remove a machine from the count, then neither does silence. And neither does losing track of it entirely. Out there right now are counted machines that stopped talking decades ago. Machines that landed and died. Machines that crashed at coordinates nobody has ever found. Some of them are still standing exactly where they stopped. And photographs prove it. There is an observatory in the Davis Mountains of West Texas, a couple hours' drive from anything, where on clear nights a team fires a laser at the moon. The beam goes up through the dome, crosses 250,000 miles, and lands on a patch of lunar ground in the Sea of Tranquility, where it hits an object about the size of a laptop, tilted toward Earth on a small stand. The object is a panel of 100 fused silica corner cubes, the same optics as Lagios, and it does the only thing it has ever done. It sends the light straight back where it came from. A few photons out of every quadrillion complete the round trip. The observatory clocks them, and the distance to the moon comes out accurate to about an inch. Neil Armstrong and Buzz Aldrin set that panel down on July 21st, 1969. A few hours before they left, every other piece of equipment they deployed died within weeks or years. The reflector has been in continuous service for 57 years, with no power source, no electronics, and no moving parts. And it's produced one of the longest-running experiments in physics, tracking the moon's slow retreat from Earth at about 1.5 inches a year and testing Einstein's account of gravity to brutal precision. The oldest working scientific instrument on another world is a mirror, and it will keep working for as long as anybody bothers to aim a laser at it. That mirror sits in the middle of a debris field, and the debris field is all still there. Photographed from lunar orbit at high resolution, Tranquility Base looks exactly like the day it was abandoned. The descent stage of the lunar module Eagle, standing on its 4 legs where it landed. Its gold foil presumably long since bleached and brittle. The flag, knocked flat by the ascent engine blast. By Aldrin's own account, bootprints in dust that nothing disturbs. On a world with no wind, no rain, and nobody to step on them. The cameras, the tools, the backpacks the crew threw out to save weight before liftoff. About 100 pounds of discarded equipment and 1 working mirror, arranged around a landing stage, untouched for 57 years. Multiply that scene across the whole moon, and you have the first off-world archaeological record. 6 Apollo descent stage, 3 lunar rovers, the electric cars of Apollo 15, 16, and 17, parked where their drivers left them. Batteries dead since 1972. 2 Soviet robotic rovers, the Lunokhod, 8 wheeled machines that drove miles by remote control years before anybody imagined a Mars rover, one of which was tracked down decades later by researchers who found its reflector still answering laser pulses. Dozens of crashed rangers and surveyors and lunars. And in the last few years, a new generation of commercial landers, some standing proud, some lying on their sides after touchdowns that did not quite work. The moon holds well over 100 tons of human hardware in a museum whose climate control is the vacuum itself. Nothing rusts. Nothing rots. Nothing blows away. The only erosion is micrometeorite dust, falling like the slowest snow imaginable. And it will take millions of years to soften an edge. Venus keeps the opposite kind of museum. Between 1970 and 1985, the Soviet Union landed a series of machines called Venera on a world with a surface temperature around 860 degrees Fahrenheit and pressure 92 times Earth's, equivalent to being half a mile down in the ocean. The landers were built like submarines, chilled before entry, and engineered to buy time rather than survive. Venera 7, the first to land working, transmitted for 23 minutes. Venera 13, the best of the line, lasted 2 hours and 7 minutes and sent back colour photographs of an orange rock-strewn plain under an orange sky. Pictures that remain, 44 years later, the only images ever taken on the surface of Venus. Every one of those machines is still down there, and every one has spent the decades since being cooked and crushed. Titanium pressure vessels pitted by corrosive air, a row of Soviet engineering entombed on the one nearby world that actively destroys its monuments. Then Mars, which has collected more dead machines than any world but ours. The two Viking landers of 1976, which worked for years and then went quiet, one of them ending on a software update that went wrong. Pathfinder and its toy-sized rover Sojourner, which in 1997 made Mars landings look possible again after 20 years. And the pair that turned rover deaths into national news. Spirit drove for 6 years on a 90-day warranty before it broke through a crust of soil into soft sand, dug itself in trying to escape, and froze during the Martian winter. A stationary science platform to the end. Opportunity drove 28 miles across 14 years, the marathon champion of another planet, until a planet-wide dust storm in June of 2018 blacked out the sky over it for months and starved its solar panels. Mission Control transmitted more than 1,000 recovery commands through that fallen winter. Nothing came back. On February 13th, 2019, they sent the last one, and a room in Pasadena played a wake-up song to a machine that could not hear it. And the mission was declared over. Spirit and Opportunity sit where they stopped, alongside Sojourner, the Vikings, the crashed Soviet landers, and the wreckage fields of every entry system that ever shed a heat shield over that planet. Some future traveller with a good map could tour half a century of American and Soviet engineering without leaving the northern hemisphere of Mars. This is really Rule 5 with the geography changed. A machine that landed on another world and died is not a loss to the count. It is the count at its most literal. Spacecraft totals are becoming, world by world, a physical inventory, an actual pile of machines standing in actual places, waiting to be visited. About 300 machines left Earth, and a large fraction of them are, at this moment, parked on the surfaces of other worlds, intact, locatable, permanent. Locatable. That is, when things went well, some machines reached other worlds and were never seen again. One spacecraft disappeared for 33 years and came back, and when it did, professional astronomers logged it as a new moon of Earth. On the night of September 3rd, 2002, an amateur astronomer named Bill Jung was working through images from his small private observatory near Benson, Arizona, when he found a point of light that moved. Moving points of light are how asteroids announce themselves, and Jung had found plenty. He reported it through the standard channels, and it got the standard sort of designation for a new rock, J002E3. Then the orbit computers went to work and the object stopped making sense. It was not going around the sun. It was going around the Earth, in a huge loose loop out beyond the moon. And nothing natural holds an orbit like that for long. Astronomers ran the path backward and found that the thing had been captured by Earth's gravity only months earlier. After decades of drifting around the sun, something had arrived. The question was what? The University of Arizona pointed a telescope at it and took a spectrum, reading the sunlight coming off its surface. The surface was not rock. The colours matched titanium dioxide paint. The white paint used on American rockets in the 1960s pushed the trajectory back far enough, and the answer assembled itself. J002E3 was the third stage of the Saturn V that launched Apollo 12 in November of 1969. The stage that threw Pete Conrad and his crew toward the moon was supposed to end up in orbit around the sun. And it did. And after 31 years of quiet circling, it wandered back through the one door in space that leads home. Got itself temporarily caught by the planet that built it. Made a few slow loops past the moon while astronomers scrambled to figure out what they were looking at. And then, in June of 2003, slipped back out into solar orbit. Projections say it may come again in the decades ahead. A 50-foot piece of Apollo, painted white, coming and going on its own schedule, getting logged as a new moon each time somebody forgets. By our rules, a spent rocket stage is not a spacecraft. So J002E3 sits outside the count. It earns the front of this chapter anyway, because it proves something the count depends on and rarely admits. We lose track of what we launch. Not small things, 50-foot things, from the most famous program in the history of flight. And when the lost thing is a spacecraft, Rule 5 holds, scent is sant. So the books carry a quiet population of machines that exist on paper and somewhere in reality, with nothing connecting the two. The most personal of them is Snoopy. In May of 1969, Apollo 10 flew the entire moon landing mission, except the landing, the dress rehearsal, and its lunar module, call sign Snoopy, carried Tom Stafford and Gene Cernan to within 9 miles of the surface. After the crew transferred back to the command module, Snoopy's ascent stage was cast off and its engine was fired to burn off the remaining fuel, which flung it out of lunar orbit entirely and into orbit around the sun. Every other lunar module ever flown was either crashed into the moon or burned up in Earth's atmosphere. Snoopy alone is still out there, the only flown lunar module in existence, and nobody knows exactly where. In 2018, a team of astronomers in the United Kingdom announced that a small object catalogued in solar orbit matched what Snoopy's path ought to look like, and put the odds high while calling it unproven, confirming it would take a close look nobody has flown. So the ledger holds an entry for a crewed spacecraft, a national treasure by any museum's standard, whose current address is, approximately, the inner solar system. Mars has a wing of this missing museum to itself. In December of 1999, NASA's Mars Polar Lander reached the planet's south polar region, began its descent, and was never heard from again. The failure review concluded the most likely cause was heartbreaking in its smallness. The landing legs, deploying on the way down, probably jolted a sensor, and the flight software read that jolt as touchdown and shut the engines off while the machine was still perhaps 130 feet up. It has never been found. Orbital cameras have photographed candidate bright spots in the search zone for 25 years without a confirmed identification. Somewhere near the Martian South Pole there is a crash site with an American flag decal in it. Location unknown. Its British cousin got a better ending. Beagle 2. A lander built in the United Kingdom and carried to Mars by a European orbiter. Was released on schedule in December of 2003 and was supposed to call home on Christmas morning. The call never came, and for 11 years Beagle 2 was written off as a crater. Then, in January of 2015, analysts studying high-resolution orbital images found it, intact, on the surface, in one piece, right where it should have been. The pictures showed what had gone wrong, and the cruelty of it was almost artistic. The lander had survived entry, descent, and touchdown perfectly. And then, unfolding its 4 solar panels like petals, it stopped 1 or 2 panels short. The panel that never opened was covering the radio antenna. Beagle 2 worked, sat there powered under the Martian sun, and had no way to say so. It may have gone on operating for some time, running its sequence, taking readings it could never send. Nobody will ever know, because the only instrument that could have told us was the one behind the panel. Which brings us to the machines that are missing on purpose. Scattered through the tracking catalogue are entries that consist of a number, an orbit, and nothing else. Objects the radars follow faithfully, while nobody can say what they are or where they came from. Alongside them is a larger category. The payloads whose owners will not say what they are, the National Reconnaissance Office, the agency that runs America's spy satellites, launches machines identified only as USA and a number. No purpose stated. No orbit published. Other countries do the same under their own labels. These are spacecraft beyond any doubt. Some of the largest and most expensive ever built. And the public books record them as a name and a launch date, except that secrecy in orbit has a structural weakness. Orbits are physics, and physics is public. A satellite big enough to matter reflects enough sunlight to be seen. And for decades, a small international community of hobbyists, a retired engineer in Canada, an analyst in the Netherlands, observers from Europe to South Africa, has made a quiet sport of finding the classified fleet. They stand in backyards with stopwatches and binoculars, time the second a moving light crosses between two known stars, feed the timings into orbit calculations, and publish the results. When a classified satellite maneuvers, they notice within days and recompute. The unofficial catalogue of secret American spacecraft, maintained by amateurs for free, is accurate enough that the professionals read it, and its existence settles a nice point. You can classify a mission. You cannot classify the sky. Add up the missing wing. A lunar module somewhere sunward. Probably found. Not confirmed. A polar lander under the Martian ice. Never found. A British lander found after 11 years. Mute and intact. Rows of catalogue numbers marked unknown. A shadow fleet tracked by volunteers because its owners will not discuss it. Every one of these has an entry, and Rule 8 covers them all. If it was sent, it is counted, whether or not anyone alive can point to where it is. The books do not require a current address. Splitting machines, destroyed machines, dead machines, lost machines. What is left is to take the far count out to its end, where the numbers thin from hundreds to tens to ones. There is a room at the Jet Propulsion Laboratory where the walls carry live displays of every antenna in the deep space network. The three great dish complexes in California, Spain, and Australia that talk to everything humanity has beyond Earth orbit. Each active link is a line on the board, spacecraft name, antenna number, data rate. On any given day, the board shows a few dozen names, and that is the entire conversation. Everything our species is saying to the solar system, and everything the solar system's machines are saying back, fits on a screen you could read from across the room. A few dozen active links. Remember the shell, with its 16,000 working machines. Out past the moon, the working fleet of the human race is smaller than the enrollment of a kindergarten. This chapter walks out through that thinning crowd, and the numbers do the talking. One warning before we start, because two different accounting systems are about to collide, and the collision is worth watching. NASA and every other agency publish visitor counts by mission, the conventional way, counting the named spacecraft that arrived. We have spent 13 chapters building a different rule, Rule 7, which counts every machine that separated and flew its own job. Most of the time, the two systems agree. At two specific planets, they do not. And rather than hide that, we are going to say both numbers out loud, because the gap between them is the whole point of this video. Start inward. Venus has been visited by roughly 45 machines since 1962, most of them Soviet, most of them dead within hours of arrival by design. Mercury, deeper into the Sun's gravity well and brutally hard to reach, is one of the loneliest destinations in the solar system. 2 spacecraft have ever completed dedicated Mercury missions. Mariner 10 in the 1970s and Messenger in the 2000s. Bepi Colombo. The 4-machine stack from Chapter 4. He's been working its way in since 2018 and has already swung past the planet 6 separate times on flybys, with its 2 science orbiters scheduled to settle into Mercury orbit in November of 2026. 2 worlds, roughly 50 machines. Across the whole of human history, the Sun has its own small fleet, and one member deserves to have its numbers read aloud. The Parker Solar Probe, launched in 2018, flies through the Sun's outer atmosphere on repeated passes, coming within about 3.8 million miles of the surface at speeds up to 430,000 miles an hour, which makes it the fastest machine ever built. A carbon composite shield takes temperatures near 2,500 degrees, while the instruments a few feet behind it ride along at room temperature. One spacecraft, and in its category of one it holds every record there is. Mars is where the count still feels almost busy. Across 60 years, the full roster of attempts runs to about 50, more than half of which failed. A casualty rate no other destination matches. Today's working population is a handful of orbiters, and the rovers still driving around and on the most visited world beyond the Moon. Humanity's entire operating presence would fit in a parking lot. Now, cross the asteroid belt and watch the census collapse. Jupiter. NASA's official count says 9 spacecraft have visited the largest planet in the solar system. Pioneer 10 and 11. Voyager 1 and 2. Ulysses passing through. Cassini passing through. New Horizons passing through. Galileo. And Juno, which is there now. 7 of those 9 never stopped. Only 2 ever stayed, by our Rule 7. The number is 10, because Galileo's atmospheric probe separated 5 months out, flew its own trajectory, entered the atmosphere alone, and worked for 58 minutes in a place no other machine has ever been. It was a spacecraft by every test we have applied for 13 chapters. And if we drop it here to match a press release, we have been wasting your time. 10. Add Europa Clipper and Europe's Juice. Both launched and both in cruise. And the all-time Jupiter list reaches 12 machines in the entire history of the species. Saturn. The official count is 4. Pioneer 11. Voyager 1. Voyager 2. And Cassini. By Rule 7, it is 5. Because Huygens flew the last 3 weeks alone and landed on Titan on its own parachutes. And calling that a component of Cassini would be absurd. So there are 2 right answers at both planets. And by now you know exactly why. One system counts missions and one counts machines. And neither is lying. The reason 4 honest institutions publish 4 different totals for the whole enterprise is the same reason this paragraph exists. Either way, hold on to the scale. Since Cassini was flown into Saturn in September of 2017, the number of working machines at Saturn has been 0. The only funded return is a nuclear-powered rotorcraft named Dragonfly, scheduled to launch in 2028 and reach Titan in the mid-2030s, where it will fly through orange skies over the plains Huygens photographed. Uranus. 1. Voyager 2. January of 1986. A single flyby lasting hours, and nothing has been back in the 40 years since. Every close photograph of Uranus that exists, every measurement of its tipped-over magnetic field, every image of its moons, came from that one pass. Neptune. 1. Voyager 2 again. August of 1989. Hours of closest approach. Then silence stretching to tonight. The National Academies, which sets American planetary science priorities each decade, ranked a Uranus orbiter as the top large mission of the 2020s, and it remains unfunded and unbuilt. In schedules, no machine of ours will see either ice giant again before the 2040s at the earliest, which means an entire class of planet, the most common type in the galaxy by some surveys, has been examined by our species for a combined total of less than 1 working week. Pluto and the Kuiper Belt. 1. New Horizons. July of 2015. 9.5 years of flight for a flyby that crossed the Pluto system in a single day, followed 4 years later by the most distant close encounter ever attempted, a small frozen world called Arakoth, 4 billion miles out. One machine, 2 worlds, and that is the entire population of humanity's Kuiper Belt fleet. Scattered in the gaps are the specialists. The sample return missions from Chapter 10, a dozen or so asteroid and comet visitors across all history, and the observatories parked at the gravitational balance points 1 million miles out, where the James Webb Space Telescope stares at the first galaxies from a spot chosen by mathematics rather than geography, alongside a small colony of sun watchers and star mappers holding station in empty space. Add the far count up honestly. Mercury to the Kuiper Belt, every flyby, orbiter, lander, rover, impactor, balloon, helicopter, and parked observatory, and NASA's total holds a little over 300 machines across 69 years of spaceflight. The shell above your head gained more spacecraft than that in the last month. 16,000 working machines circle the Earth. One has ever seen Neptune. In the National Air and Space Museum in Washington, there is a small battered sphere, 6.5 inches across, with 4 bent antennas sticking out of it. The label identifies it as the Vanguard Test Vehicle 3 satellite. It has a scorched, roughed-up look that the polished replicas around it lack, and it comes by that look honestly, because this is the actual satellite that was sitting on top of the Vanguard rocket on December 6th, 1957, when the rocket rose 4 feet and exploded on national television. Here is the detail that turns a famous embarrassment into a counting problem. The blast threw the little satellite clear. It landed in the scrub near the pad, dented, and its transmitter kept running on battery. Engineers and reporters at the Cape could hear it beeping from the wreckage. A spacecraft calling out its status from the bushes beside its own burning rocket. Columnists suggested somebody walk over and put it out of its misery. So does it count? It was a complete spacecraft. It was flight hardware, not a mock-up. It worked before, during, and after its launch attempt. The one thing it never did was reach space. And on that single fact, the answer is no. Rule 2, written back in Chapter 3, holds the line: orbit or escape, or no entry. The beeping grapefruit in the bushes is the most sympathetic case anyone will ever bring against that rule. And the rule survives it, because the alternative turns the count into a catalogue of intentions. We record what humanity sent. Vanguard TV3, through no fault of its own, was never sent. It was only launched. That distinction, sent versus launched, sorts every failure in 70 years of spaceflight. And the failures sort into a ladder. The bottom rungs are the cold ones, destroyed before reaching space, which covers the Vanguard explosion and the hundreds of rockets across every nation's early programs that rose and tumbled and got blown up by range safety, taking complete spacecraft with them, some carrying years of a laboratory's work. Then, one rung up, the ones that reach space and fail to reach orbit, where a booster clears the boundary and an upper stage misfires and the payload arcs over into an ocean. That machine was in space, briefly and indisputably. Rule 2 asks about orbit, not altitude. Still no entry. The answer changes on the 3rd rung, and this is where the ladder gets interesting. Reached orbit. Wrong orbit. When an upper stage underperforms and strands a satellite in a lopsided, useless path, the machine is in orbit, circling the Earth, tracked by the radars for years. It was sent. It arrived somewhere. The entry stands, with a sad annotation, and the books are full of these. Communications satellites that burn their entire onboard fuel supply, climbing to the orbit their rocket failed to provide, arriving at their stations years late with their working lives cut in half. Satellites that never climbed at all and simply circled uselessly until the atmosphere took them back. Fourth rung. Reached orbit dead. Some machines arrive with no pulse. The launch is perfect. The deployment is perfect. And the satellite never phones home. A brick in a flawless orbit. The radars track it either way. Rule 5 covers it. Dead still counts. And the operators are left running a months-long séance, transmitting commands to a machine that may or may not be listening, before filing the insurance claim. Fifth rung. And now the failures start costing worlds. In August of 1993, NASA's Mars Observer. The agency's returned to Mars after 17 years. There was 3 days from arrival when contact was lost during a fuel system pressurization sequence. The most likely explanation is a propellant line rupture that sent the spacecraft tumbling, though nobody has ever confirmed it. It sailed past Mars, mute, and entered orbit around the Sun, where it remains, a fully built, fully fueled observatory drifting in the dark. Counted, in full, it reached space, left Earth, and flew most of the way to another planet. 5 years later, Japan's Nozomi suffered its own crippled cruise and likewise sailed past Mars into permanent solar orbit. Also counted, there is a small fleet of these ghost ships circling the Sun, missions that got 99% of the way, and the books hold a place for everyone. Sixth rung. Arrived. Failed at the destination. The rung Mars owns almost outright. The Soviet Mars 3 lander touched down softly in 1971, began transmitting the first picture ever sent from the Martian surface, and went silent after about 20 seconds. Forever. Probably killed by the planet-wide dust storm raging around it. 20 seconds of function after a 200-day cruise, and it is counted identically to Opportunity's 14 years. 1 entry each. Mars Polar Lander from the last chapter. Counted. Address unknown. Mars Climate Orbiter. Lost in 1999 to the most famous unit conversion error in engineering history. One team working in pounds of force and another in newtons. The spacecraft steered by that mismatch too deep into the atmosphere where it broke up or skipped off. Fate never determined. Counted. 7th rung is the one that ends this ladder on something other than heartbreak. Arrived, broken, and worked anyway. In 2019, Israel's small lunar lander Bereshit crashed into the moon when its main engine cut out during descent. And its impact site, photographed from orbit, joined the archaeology of Chapter 12. In 2023 and 24, a new generation of commercial lunar landers reached the surface with mixed dignity. One tipping over after a leg caught, another settling onto its side, and several of those compromised machines powered up anyway, made contact, and returned data from wherever their antennas happened to be pointing. Sideways on the moon is still on the moon. All counted. Climb back down, and the principle underneath every rung is the one the grapefruit established. We do not grade on success, and we do not grade on merit. One question decides it. Was the machine sent? Meaning, did it reach orbit or leave the Earth? And everything after that. Triumph, or silence, or a wrong orbit, or 20 seconds of life, or a decade of ghost cruising around the Sun, goes in the annotation and never in the entry. The Soviet Union attempted roughly 20 Mars missions and landed a working machine for 20 seconds. The United States has flown Mars missions for 60 years and lost about a third of everything it sent. Every attempt that got away from Earth is in the count, because the count is a record of reach, not of grasp, which leaves one thing unexamined, and it has been hiding under this entire video. Rules do not apply themselves, and entries do not write themselves down. Somewhere, actual people at actual desks maintain the actual lists. 3 rooms, 3 ledgers, 3 very different kinds of quiet. The first is in Vienna. In the United Nations complex on the bank of the Danube, the Office for Outer Space Affairs occupies a modest set of floors there, and among its duties is a document with a title only a treaty lawyer could love: the Register of Objects Launched into Outer Space. It exists because of a 1970s convention signed in the aftermath of the early space race, under which every launching state is obligated to report what it puts up. A submission arrives as paperwork: a diplomatic note listing a name, a launch date, basic orbital parameters, and a general description of function, and a small staff enters it into the record. It is the closest thing our species has to a civil registry for spacecraft, the orbital equivalent of a hall of births, and it runs late. Countries file when they file. Some submissions arrive months after launch, some arrive years after, and a stubborn few never arrive at all. By the office's own accounting, as of August of 2025, roughly 21,750 functional space objects had been launched into orbit or beyond in all of history, and about 91.5% of them had been formally registered. That sounds impressive until you flip it over. Nearly one object in 12, by the International System's own admission, is undocumented. The world's master registry for spacecraft is missing close to 2,000 entries. Everyone involved knows it, and there is no enforcement mechanism beyond diplomatic embarrassment, which, when the unregistered object is a reconnaissance satellite, is a price its owner already decided to pay. The second room is at Vandenberg, the one we started in, and its quiet is the quiet of a night shift. The squadrons that maintain the American tracking catalogue work around the clock, because the sky keeps no office hours. Somewhere on that floor tonight, there is a young airman a year out of technical school, watching new radar tracks populate after a launch out of Cape Canaveral, working through the list, matching what the radars found against what the operator said would be aboard. 58 objects expected, 61 tracks. 2 of them will turn out to be deployment hardware. The third takes 3 days to resolve, and until it does, it sits in the system with a number and no name. That is the job. This catalogue does not care about paperwork or treaties. It cares about radar returns. If a thing is up there and big enough to track, it gets a number. Whether it is a working satellite, a dead one, a spent stage, a Linskap, or an entry that will sit labelled unknown for the next 40 years. Vienna records what nations admit. Vandenberg records what physics reveals. The 2 lists describe the same sky and have never once matched. The third room is the office in Cambridge, Massachusetts, and by now it needs no introduction. Jonathan McDowell's catalogue exists precisely because the first 2 rooms disagree, and his method is closer to journalism than to either diplomacy or radar. He reads launch announcements in a dozen languages, cross-references the Vienna filings against the Vandenberg catalogue, chases down discrepancies, corrects errors in both directions, assigns his own consistent designations, and publishes the whole thing freely with his reasoning shown. When a payload flies under 2 names, his list reconciles them. When a nation quietly omits a military satellite from its treaty filing, his list notes the omission. The professionals in the first 2 rooms read the third room's newsletter. That is the actual state of the art in counting spacecraft in the 21st century. 2 government systems, and a referee with a spreadsheet. Why can the 3 never agree? The reasons stack. Time skew. First, Vienna lags launches by months and years. So on any given date, it describes a younger sky than the radars do. Names. Second, one spacecraft can carry a mission name, a manufacturer's designation, a national registry entry, a tracking number, and a marketing name. All different. Sorting one machine's 5 aliases from 5 different machines is real detective work, and mistakes in it have taken years to unwind. Secrecy. Third, the classified fleets appear in every catalogue as stubs. A number and an orbit in one, a name and no orbit in another, a blank in the third, and circling those stubs, as Chapter 13 found, is the volunteer network with their stopwatches, publishing the orbits the owners withhold, definitions. Fourth, and this one runs deepest, the 3 rooms do not share a rulebook. One counts functional objects. One counts trackable objects. One counts whatever the evidence supports. Every boundary case in this video, the split landers, the stranded orbits, the dead arrivals, the station modules, lands differently in different rooms, and nobody has the authority to impose an answer, because no such authority exists. There is no head office of the sky. Fragmentation and re-entry. Last, the population changes daily. Objects break up and multiply. Objects fall and vanish. And more than 3 tracked objects come down every day. Each one a subtraction that 3 systems process on 3 schedules. Run 1 launch through the whole pipeline and the machine becomes visible. A rocket lifts off from New Zealand carrying 40 small satellites. Within days, Vandenberg has 40 new tracks and 40 new numbers, some with clean identifications, some pending analysis. Within weeks, McDowell's catalogue has reconciled the operator's deployment list against the radar tracks and flagged 2 CubeSats that never made contact and one that may have failed to separate from its dispenser, a distinction that changes the total by 1. Within a year or two, a diplomatic note reaches Vienna registering most, or all of the 40, in language negotiated by lawyers. 3 rooms, 3 arrival times, 3 totals, 1 sky. The disagreement is not a scandal and it is not incompetence. Every room answers the question it was built to answer. Honestly, the problem was never bad record keeping. Spaceflight created more kinds of things than any single ledger was built to hold, and it kept inventing new kinds faster than the definitions could close around them. Needles and mirrors, stations assembled in flight, machines that split into 4, machines that fly twice, machines destroyed on schedule, machines lost and lost again, which means the question in the title has been answerable all along, as long as it gets answered the way the counters themselves would answer it, in layers, with the rules attached. There is one more layer to visit first, out past everything in this video, where 5 machines are leaving and not coming back. Outside Canberra, Australia, in a valley picked decades ago for its radio quiet. The largest dish in the southern hemisphere spends part of certain nights pointed at a patch of sky in the constellation Pavo. Deep Space Station 43 is the only antenna on Earth with the power and the position to command Voyager 2. And when it locks on, the 2 ends of that conversation could not be less alike. On one end, a 70-metre dish, receivers chilled to a few degrees above absolute zero, a national facility with a staff and a budget. On the other end, a machine built during the Ford administration, 13 billion miles out, answering back at 23 watts. That link is one of 5 machines, in the entire history of our species, are on paths that leave the solar system and never return. Pioneer 10 went first, launched in March of 1972, the first spacecraft to cross the asteroid belt and the first to reach Jupiter. Its flyby in December of 1973 threw it onto an escape trajectory, and it spent the next 3 decades receding and still talking. The signal thinned as its power source decayed, and the last faint contact came in January of 2003, from about 7.5 billion miles away. Nobody has heard it since. It is still going, aimed in the general direction of the star Aldebaran, a trip that will take about 2 million years. Pioneer 11 launched 13 months behind its twin, used Jupiter to reach Saturn, became the first machine ever to see that planet up close in September of 1979, and then followed its own escape path out. Its transmitter went quiet in 1995. It travels almost opposite from Pioneer 10, and both carry the gold plaques, the engraved figures of a man and a woman and the map of pulsars pointing back to our sun. A return address on 2 letters that will almost certainly never be opened. Voyager 2, launched in August of 1977, flew the Grand Tour and remains the only spacecraft ever to visit all 4 giant planets. In 2018, it became the second machine to cross into interstellar space. It is still alive. Its power supply drops about 4 watts a year. Its instruments are being switched off one at a time on a schedule written years in advance. And the engineers managing that decline expect to keep some science flowing into the early 2030s. Voyager 1 launched 16 days after its twin on a faster path and is now the farthest human-made object in existence. More than 15 billion miles out and pulling away at about 38,000 miles an hour. It crossed into interstellar space in August of 2012, the first machine to leave the sun's bubble. And it still answers, through memory failures and thruster swaps and repairs that have become legend in their own right. No spacecraft currently operating, under construction, or funded for launch is expected to overtake it, which means it will hold that record well past the working lifetime of anyone reading a budget today. And New Horizons, the youngest of the 5, launched in January of 2006 on the fastest departure from Earth ever flown, the Pluto machine from Chapter 14. It is healthy and expected to keep transmitting into the late 2030s, mapping the outer edge of the Sun's domain as it goes. 5 entries, 2 silent, 3 talking. That is the complete membership of the most exclusive category in the books. And the number has not changed since 2006. No funded mission will add a 6th. Now the part that almost never gets said. 5 is the number of spacecraft leaving. It is not the number of objects leaving. Every one of those 5 needed a final rocket stage to throw it onto its escape path. And a rocket stage, having burned, does not politely turn around. It follows. The clearest case is New Horizons. Its 3rd stage, a solid motor called a Star 48B, burned for about a minute and a half in January of 2006 and pushed the spacecraft to its record speed. Then it separated, and physics did the rest. That empty motor casing is on its own escape trajectory, trailing New Horizons on a slightly different path, and it crossed the orbit of Pluto around the same time the spacecraft did, a dead steel drum making the same historic journey with no instruments, no name, and no press coverage. Several associated upper stages from the Pioneer and Voyager launches are likewise on long-term heliocentric or escape paths. Derelict pieces of 1970s hardware coasting outward alongside the missions they served. So the true census of human objects departing the solar system is not 5, it is 5 spacecraft, plus a handful of dead stages that will get just as far. And the split between those 2 figures is this entire video compressed into one line. The stages are leaving just as permanently. They are travelling just as far. In 2 million years. Anything that intercepted that Star 48B casing would be holding a genuine artifact of Earth, no less authentic than Voyager's golden record. And the books still say 5, because we count machines built to do a job after launch delivery. And a burned-out motor's whole reason for existing was the delivery itself. That is Rule 9. And it is Rule 3, refusing to bend under the most tempting pressure in the entire count, which means the most famous number in this story, the 5 machines leaving forever, is itself the product of a definition. Change the rule and 5 becomes 10 or 11. Keep the rule and a piece of steel that will outlast the human species goes unrecorded. There is no version of the number that is not a decision. Out there tonight, 3 of the 5 are still transmitting, on the order of 20 watts apiece. Across distances that turn those signals into something a receiver has to be cooled almost to absolute zero to hear. The other 2 went quiet decades ago and are running dark, on the same headings, at the same speeds, carrying the same plaques. Nothing is going to stop any of them. Nothing is going to catch them. Time to close the books. Back to Vandenberg. where this started. Another night. Another rocket up the California coast. Another dispenser rack letting go 200 miles over the Pacific. Another screen in a control room counting confirmed separations. That screen ticks upward tonight the way a screen somewhere has ticked upward. On average, more than once a day for years running, the number never sits still long enough to photograph. So we state it the way the people who keep these records state it, pinned to a date, rounded with respect, and layered. As of July of 2026, the first answer: machines placed into Earth orbit since Sputnik. Approximately 27,490. That is the broad count in full. Every satellite and capsule and station module and rack released payload that ever achieved orbit. Counted under the rules we wrote. One entry per machine with its own job. Dead or alive. Famous or classified. 6 tons or 6 pounds. The second answer: machines still up there. Approximately 18,840. The rest, more than 8,500 of them, are no longer in space. Most burned up on re-entry. Some came down on purpose. Capsules under parachutes and shuttles on runways and sample canisters recovered off the desert floor. A few came apart high up and dropped surviving pieces into the ocean. The third answer: machines still working. Approximately 16,100. The living fleet, nearly all of it aimed downward, running navigation and weather and broadband and timing for the planet underneath. The invisible utility from that Nebraska highway at 4 a.m. And the fourth answer: machines that ever left Earth orbit and went somewhere else. A little over 300. In 69 years. The moon landers and the Mars rovers. The comet chasers and the sample returners. The ghost ships circling the sun. The Archaeology standing on 3 worlds. The 10 or 12 visitors Jupiter has ever had. The 1 machine that has ever seen Neptune. And the 5 that are leaving. 4 answers. 1 question. And the gap between the largest and the smallest is a factor of 90. Every layer is correct. Which one is the answer depends entirely on what you meant when you asked. And by now, you know exactly what you meant. The rules that built those numbers fit in a breath each. So here they are. All 9. Read once. For the record, a machine placed in space with a job of its own is counted. And going silent does not remove it. Touching space is not enough. Orbit or escape is the line. We count machines, not missions. 1 machine is 1 entry. Whatever it weighs, however long it lives, however many shared its rocket, dead still counts. Shrapnel never does. Machines built, not trips taken. Every component that separates and flies its own job counts separately, and structure that merely falls away does not. Sant is sant, even when nobody can point to where it went. And rocket bodies stay out, even the ones leaving the solar system forever. 9 rules. Every one of them a choice. Change any one and the totals move. Which is why 4 honest institutions publish 4 different numbers, and why the honest answer to the title has to be a sentence rather than a figure. Humanity has sent tens of thousands of working machines into space. Almost all of them stayed wrapped close around the Earth. Only a few hundred ever truly left, and 5 are never coming back. 1 more pass over the ledger before we shut it. Because there is a habit this count has that nothing else quite shares. It has no exits. Only annotations. Vanguard 1. Dead since Johnson was president. Still circling. Senior member of the sky for another 200 years. The West Ford clumps. Kennedy-era copper. Still up. Lagios and it plaque. Holding orbit for the next 8 million years. The Mirror at Tranquility Base. Still answering lasers from a mountaintop in Texas after 57 years. Snoopy. Somewhere sunward. Probably identified. The ghost ships that missed Mars. The wreckage fields mapped from Martian orbit. 2 pioneers. Silent. Outbound. And a burned-out steel motor casing chasing new horizons out of the solar system. Uncounted by our own rule. On track to become one of the oldest surviving objects our species ever made. Tonight the screen at Vandenberg confirms the last separation of the evening. And the count ticks up again. To a number that will be wrong by tomorrow. It has been moving like that for 69 years. It started on a night in October of 1957, over a country that went out to its backyards to look for the future, and found a point of light crossing the stars, and pointed at it, and was pointing at the wrong object. The count began confused, and it has never once stopped moving. And above your head right now, every entry still up there is doing exactly what physics told it to do on the day somebody wrote it into the books and let go. Thanks for watching. Somewhere in this count there is one machine that stuck with you. The grapefruit beeping in the bushes beside its own burning rocket. The lander on Mars that worked perfectly with its antenna covered. Or the steel casing that no rule counts and that will outlive us all. Tell us which one in the comments.